Hi students, in the previous class we discussed about the working principle of DC motor, that is how the DC motor is going to work, and Fleming's left hand rule. And now in today's class we will discuss regarding back EMF, right? So for the point of examination, the back EMF is very important because many times they have asked this derivation regarding back EMF in the previous question papers, right? So in order to understand back EMF, we will consider this circuit diagram, right? See what is there in the circuit diagram, right? So there is one motor with armature resistance Ra, and there is some field with field resistance RSH. As it is connected in parallel, we are going to call it as shunt resistance, and across these two we are going to apply voltage V, right? So ಏನೈತ್ರಿ ಈ ಸರ್ಕ್ಯೂಟ್ನಾಗ we are going to apply a voltage V parallel to motor and field resistor, right? So now we will apply KCL to this node. What does our KCL states? KCL states that current entering the node is equals to current leaving the node, right? So what is the current entering the node here? See, here current IL is entering and current ISH and I are leaving, right? So if I apply KCL, what I will get? I will get IL is equals to IA plus ISH, right? So now current IA will flows through the armature resistance Ra or motor, right? So due to that the motor will rotates. That is, when current IA flows through the armature conductor, a torque will be produced and armature rotates. And next, see here, next when current ISH flows through the field resistor, right? So what happens? Due to there is change in magnetic flux, because some current is flowing through the field, there will be change in magnetic flux, right? So according to Faraday's law, the rate of change of magnetic flux will be called as what? EMF. That is, an EMF is induced in the field resistance, that is across armature conductor. And what about the direction of EMF, right? So always the induced EMF will be opposes the cause for it according to Lenz's law, right? So E is equals to minus d phi by dt. ಏನಾಗತ್ರಿ, field resistor ನಾಗ current ISH ಹೊಂಟೈತಿ. Because of that ISH there will be change in magnetic flux here, right? So change in magnetic flux induces an EMF according to Faraday's law. E is equals to d phi by dt, right? So what about the direction of that induced EMF? It will always opposes the cause for it. That is, it will always opposes the cause due to which an EMF is induced, right? So now see here, the applied voltage V drive the current through armature conductor against the opposition of back EMF, right? So ಈಗ ಒಂದು ಏನಾರ ನೀವು ಅಪೋಸ್ ಮಾಡ್ಬೇಕಂದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೀವು ಕುಸ್ತಿ ಆಡೋ ಹೊತ್ನ್ಯಾಗ ನೋಡ್ಬೋದು, ಅವ್ರು ಹಿಂಗೆ ಕೈ ಹಿಡಿದು ಅವ್ರನ್ನ ಅಪೋಸ್ ಮಾಡ್ತಾರಂದ್ರೆ ಯು ನೀಡ್ ಟು ಅಪ್ಲೈ ಸಮ್ ಮೆಕ್ಯಾನಿಕಲ್ ವರ್ಕ್ or we need to apply some mechanical force, right? So hangate ಇಲ್ಲಿ ಏನು ಕರೆಂಟ್ IA ಹೊಂಟೈತಲ್ಲ, ರೈಟ್? ಸೊ ಇದು ಇಲ್ಲೇನು EMF ಜನರೇಟ್ ಆಗಿರ್ತಲ್ಲ, ಈ EMFಗೆ ನಾವು ಏನಂತೀವಿ? ಬ್ಯಾಕ್ EMF ಅಂತೀವಿ. ಇದನ್ನು ಅಪೋಸ್ ಮಾಡಬೇಕಾದ್ರೆ ದೇರ್ ಶುಡ್ ಬಿ ಸಮ್ ಮೆಕ್ಯಾನಿಕಲ್ ಪವರ್, ದೇರ್ ಶುಡ್ ಬಿ ಸಮ್ ಮೆಕ್ಯಾನಿಕಲ್ ವರ್ಕ್, right? So due to that mechanical work the motor will starts rotating, or the motor will be continuously rotating, right? So ಈಗ ಅಕಸ್ಮಾತ್ ಇಲ್ಲಿ ಏನರ, if there is no field resistance, if there is no field resistance, ಅವಾಗ ಏನಾಗುತ್ತೆ, there will be no back EMF, no back EMF. If there is no back EMF, ಅವಾಗ ಏನಾಗುತ್ತೆ ರೀ, there will be no opposition for armature current. If there is no opposition for armature current, then there will be no mechanical power, right? So in that case the motor will not rotate, right? So if you want to make your motor to continuously rotating, then there should be sufficient amount of back EMF should be there. ಈ ಬ್ಯಾಕ್ EMF ಬರ್ಬೇಕಂದ್ರೆ ಏನಾಗಬೇಕು, there will be some field resistor, right? ಸೊ ಫೀಲ್ಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇತ್ತಂದ್ರೆ ಅಲ್ಲಿ ಫೀಲ್ಡ್ ಕರೆಂಟ್ ಅಥವಾ ISH ಕರೆಂಟ್ ಹೊಂಟಿತ್ತಂದ್ರೆ that current will induces back EMF, and in order to oppose that back EMF there will be some mechanical power takes place, right? So due to that the motor will rotates continuously, right? So now what we will do is we will apply KVL for this loop, right? So ಇಲ್ಲಿ ಏನಾಯ್ತು ನೋಡ್ರಿ, this is polarity of voltage. Next current is flowing from upwards to downwards, that is like this ISH, right? So already DC circuit ಹೇಳೋ ಮುಂದೆ ಹೇಳತ್ರಿ, ಯಾವಾಗಲೂ ಕರೆಂಟ್ ಏನಾಗತ್ತೆ ರೀ, ಹೈಯರ್ ಪೊಟೆನ್ಷಿಯಲಿಂದ ಲೋವರ್ ಪೊಟೆನ್ಷಿಯಲಿಗೆ ಹೋಗ್ತೈತಿ. ಅಂದ್ರೆ ಕರೆಂಟ್ ಮ್ಯಾಗಿಂದ ಕೆಳಗೆ ಬರಾಕತ್ತೈತಿ ಅಂದ್ರೆ ದಿಸ್ ಈಸ್ ಹೈಯರ್ ಪೊಟೆನ್ಷಿಯಲ್, ದಿಸ್ ಈಸ್ ಲೋವರ್ ಪೊಟೆನ್ಷಿಯಲ್, ರೈಟ್? ಸೊ ನಾ ಹೇಳೋದು ಅರ್ಥ ಆಗತ್ತಲ್ರಿ, ಆಲ್ವೇಸ್ ಕರೆಂಟ್ ವಿಲ್ ಬಿ ಫ್ಲೋಯಿಂಗ್ ಫ್ರಮ್ higher potential to lower potential. Now we will apply KVL for this loop, right? So ಏನಾಗುತ್ತೆ, voltage V, there will be same sign, this is also plus because we need to apply KVL like this. This is also plus, this is also plus, there will be same sign, then we will get change in polarity, that is minus EB is equals to, right? So what is KVL? Summation of V is equals to summation of IR, right? So summation of V is equals to summation of IR, right? So ಏನಾಗುತ್ತೆ, V minus EB equals to IA into RA, right? So ಯಾಕಂದ್ರೆ here I cannot take ISH because already I have taken EB there. One ತಗೋಬೇಕು, either you can take current and resistance or you can take voltage. ಇಲ್ಲಿ ನಾನು ಆಲ್ರೆಡಿ ವೋಲ್ಟೇಜ್ ತೊಗೊಂಡಿನಿ, therefore ISH ತಗೋಬಾರ್ದು, ಮತ್ತು ಇಲ್ಲಿ ಕರೆಂಟ್ ಯಾಕೆ ಬಿಟ್ರಿ ಅಂತ ತಲೆ ಕೆಡಿಸ್ಕೋಬೇಡ್ರಿ. V minus EB is equals to IA into RA, right? So next ನೋಡ್ರಿ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, I can write this equation as V is equals to EB plus IA into RA. Let me call this as equation number 1, right? So now what we will do is we will derive the equation for back EMF, right?